Hello, class 11th physics, chapter gravitation, important questions. A body weighs 63 Newton on the surface of Earth. What is the gravitational force on it due to Earth at a height equal to half the radius of the Earth? So, this is a clear question related to variation of g above the surface of earth. So we know that gh above the surface of earth is given by g upon 1 plus h by r whole square. Well, they have given weight of the body, so there's no issue. We can multiply both sides with mass. So mgh is equal to mg upon 1 plus h by r square, and mgh we have to find. Mg we know 63, so we can put that later on. Right now we'll proceed like that. And here height equal to half the radius of earth. So it's so simple. Mg, here I am writing weight at a height h, so no issue. Actually, as we are doing with g, so also with w. So we haven't studied this formula. In fact, I can write here w. On next step I will write it w, that is weight of that body on the surface of earth. And here it will be 1 plus h is half of the radius of earth, so h equal to r by 2, and r is also there, square. ये कट जाएगा, so it will be, ये w कर देते हैं, weight on the surface of earth upon, this is 1 plus 1 by 2 square, it is 3 by 2 square. So that will be wh equal to w upon 3 by 2 square, that is 9 by 4, that is 4 by 9, 4 by 9 into w, which is 63. 4 by 9 into 63, so 9 sevens are 4 sevens are 28 Newton. Assuming to be a sphere, uniform mass density, how much would a body weigh halfway down to the center of the earth if it weighed 250 Newton? Same type of question, this time variation in g below the earth surface. So g at depth is equal to g on the surface of earth 1 minus d by r. And once again, because weight is given, so we will multiply both sides by m. D is the depth. In the book it is written as h, but it is better to write it d. It gives us a feel that it is depth. Now this is weight of the body at d depth. This is weight of the body at the surface of earth, 1 minus halfway down, so r by 2 will get cancelled, w 1 minus half, that is half, so w by 2, and w is 250 by 2, that is 125 Newton. Here the formula minus gmm 1 upon r2 minus 1 upon r1 is more, yeah, less accurate than formula mg r2 minus r1 for the difference of potential energy between 2 points r1 r2 at a distance away from the center of earth. Choose the correct alternative. हमें ये बताना है कि ये ज़्यादा करेक्ट है या कम करेक्ट है. तो first thing, first point, G varies with R. First point. Second point, mgr2 minus r1 is not completely associated with basic definition of gravitational potential energy. So minus gmm 1 by r2 minus 1 by r1 is more accurate. There are some other evidences also, like it does not give any information about the origin, the nature of force, that is whether it is conservative or not. However, this is giving that information, and it is derived from a conservative force. So its origin we can find its origin. We can't derive relation of gravitational intensity and potential from here, but we can derive it from here. The potential energy of system of 4 particles given. Okay, so there is first system, second system, third system, fourth system, fifth system, sixth system. So there are 6 systems. Potential energy of these two, 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 and then potential energy of these two, potential energy of these two. So total potential energy will be equal to 6 times, sorry, 4 times, 4 times these things. G m m upon r. R is L with a negative sign, and 2 diagonal, minus 2 g m m, and diagonal. So we know that in a square diagonal length is L root 2. That's all. रूट 2 से 2 कैंसिल कर लेंगे. सो रूट टू ज़ा, ये इससे कटेगा, आंसर आ जाएगा रूट 2. तो क्या बचा? देयर इज माइनस जी एम, ओ सॉरी स्मॉल एम लिखा है तो स्मॉल एम ही लिखना पड़ेगा. जी एम स्क्वायर अपॉन एल, एंड विद इन ब्रैकेट 4 प्लस रूट 2. दैट्स इट. इन द अबव प्रॉब्लम फाइंड पोटेंशियल एट द सेंटर. तो सेंटर के लिए पहले डिस्टेंस निकालनी पड़ेगी. तो दिस डिस्टेंस आर, दिस आर डिस्टेंस विल बी द हाफ ऑफ डायगनल. तो डायगनल की लेंथ है एल रूट 2 अपॉन 2. इसे ऐसे ही रहने देंगे और कुछ करने की ज़रूरत नहीं. लेटर ऑन वी विल सी हाउ कैन वी सिंप्लीफाई दिस. नाउ सो एट द सेंटर ओ देर आर 4 पार्टिकल और सबका पोटेंशियल सेंटर पे निकलेगा. तो इट विल बी द एल्जेब्रिक सम. सो v इक्वल टू v1 प्लस v2 प्लस v3 प्लस v4. सो इट विल बी, actually all of them are equal, so we can say 4v1, all are equal. So it will be 4 into minus gm. एक ही आएगा, पोटेंशियल है gm अपॉन r होता है फॉर्मूला. लिख लेंगे साइड में v इक्वल टू माइनस gm अपॉन r, और r की जगह पे यहाँ पे l रूट 2 बाई 2. ओ ये ऊपर चला जाएगा. सो इट विल बी माइनस 8 gm अपॉन L रूट टू, आप रूट टू का एडजस्ट कर लेना ऑफ योर ओन, आई एम लीविंग इट हियर, रेशनलाइज करना कहते हैं जिसे, सो दैट विल बी द आंसर. सो दिस क्वेश्चन प्रिटी एडवांस्ड क्वेश्चन. यू कैन शील्ड अ चार्ज फ्रॉम इलेक्ट्रिक फोर्सेज. ये आपको पता नहीं है, ये क्लास 12th में आप पढ़ेंगे. पुटिंग इट इनसाइड अ हॉलो कंडक्टर. अगर एक चार्ज को एक कंडक्टर के अंदर अगर रख दिया जाए तो उसे हम शील्डिंग कर सकते हैं. बाहर के इलेक्ट्रिक फील्ड के इफेक्ट में हम उसे शील्ड कर सकते हैं ऐसे रख के. तो बाहर का इलेक्ट्रिक फील्ड इसे इन्फ्लुएंस नहीं करेगा, इसके अंदर नहीं जाएगा. ये मेटल के कंटेनर में अगर रख दिया तो ये बाहर का इलेक्ट्रिक फील्ड का इफेक्ट इसमें नहीं जाएगा. तो क्वेश्चन ये है कि कैन यू शील्ड अ बॉडी फ्रॉम ग्रेविटेशनल इन्फ्लुएंस ऑफ नियर बाई मैटर बाई पुटिंग इट इनसाइड अ हॉलो स्फीयर और बाई सम अदर मीन्स. आंसर इज नो, बिग नो. क्योंकि इलेक्ट्रिक फोर्स तो मीडियम डिपेंडेंट होते हैं. इलेक्ट्रोस्टैटिक फोर्सेस आर मीडियम डिपेंडेंट. But gravitational are not. That's all. An astronaut inside a small spaceship around Earth cannot detect gravity. If the space station is large, can he hope to detect gravity? Explain. Yes, because of mass. Large size, actually, they have used the term large size. Uh, well, large size corresponds to its heaviness. It is a big space station, it will be having more mass. So because of its mass, as G is equal to Gm upon R square. From the Earth toward the Sun, at what distance from the Earth's center is gravitational force on the rocket? 0. Okay, so it looks like it is a question based upon escape speed or related to some orbital speed or based upon satellite or something like that, but it is a quite different question. This is the Earth and it is fired toward the Sun. In such questions, we have to neglect influence of other planets. So let us suppose this is the entire situation. They are asking that at what distance from the center of Earth gravitational force on rocket 0. Okay, so actually the distance between Sun and the Earth is actually generally it is given, but here we know that it is 1.5 into 10 to the power 11 meter. This is a GK type question. Actually we can get it very easily. We know distance equal to speed into time, and we know speed of light is 3 into 10 to the power 8, and time taken by light from the sun to reach the earth is 8 minute 20 second, that is approximately 500 seconds. So 5 into 10 to the power 2, 5 3s are 15 into 10 to the power 10, so that is 1.5 into 10 to the power 11. It is just because sometime most of time these values we don't we can't memorize, but these are the some ways by which we can obtain it. We should know how much time light takes to reach the earth from the sun. Alright, that is a different story. So right now I am not going to write it like this. I am going to write it R. And let us suppose here, when rocket is here, gravitational force acting on it is 0. How? I will tell you later. So from here to here, let us suppose this distance is x. So remaining distance is r minus x. This is the mass. This is Earth. So me mass of Earth, ms mass of Sun. Well, now I don't have any other trick, but these values are given. If you would write it again and again, you would memorize that value, but no need to memorize. These values are given in the exam. This is 2 mass of Sun, 2 into 10 to the power 30 kg. So, well, actually, the idea is, let us suppose there is a body somewhere here. So it is being pulled by Earth as well as the Sun. दोनों तरफ खींच रहा होगा, इधर भी और इधर भी. तो अगर ये, it's not looking like it is possible or not, but see, Earth, जो sun है, it is quite big. It will produce more gravitational pull. लेकिन अगर इससे दूरी बढ़ा दी जाए तो एक कंडीशन ऐसी आएगी कि सन विल पुल दैट ऑब्जेक्ट विथ सेम फोर्स दैट ऑफ अर्थ. देखो, इसीलिए डायग्राम में भी जो मैंने अप्रॉक्सीमेट बनाया है उसमें मैंने भी ऐसे बना रखा है. इस साइड के लिए ज़्यादा डिस्टेंस दे रखी है. ज़्यादा डिस्टेंस तो इसका थोड़ा कम फोर्स होगा, और अर्थ डिस्टेंस कम है तो इसके बराबर वो फोर्स हो जाएगा. सो एट दिस पॉइंट force will be 0. Net force will be 0. Means at this point force at O, let's suppose at O, F due to Earth on that object, on that rocket. So let us suppose m, small m, is the mass of the rocket. So F due to Earth is equal to g me m upon x square, and F due to Sun is equal to g m s m upon r minus x square. If we want to go logically and want to explain every information here, we can say that net force acting on it is 0. So Fe vector plus Fs vector is equal to 0. So Fe vector is equal to minus Fs vector. And if we remove vector sign, so Fe is equal to Fs. So here what we are doing it directly. We are directly putting Fe equal to Fs. If Fs, if there is no force acting on the rocket. If no force acting on the rocket. Rocket. Now what? G m e m upon x square is equal to g m s m upon r minus x square. G will cancelled, mm will get cancelled, and now I am rearranging it, and r minus x upon x square I hope you people are getting what I am doing. ms upon me. Later on we can take root, and most of the student will think that it is going to be more difficult, but no, it is the best way to solve this problem. Now take individual division of x with this, or more space. Okay, I will arrange that. Um, but entire this space I am utilizing for illustration. So first one is m, from where we have to project that projectile, and other one is 4m, and both are having same radius. Have I written that or I missed it? Equal radii. R, R. Okay. We have to find a minimum velocity. Well, I want to tell you that it is the idea that okay, just forget about escape speed. Escape speed is something like to escape from that planet, but here we don't have to escape that object from this planet, because we have to just push it till somewhere here, and then this planet will pull it toward it. This is of mass m, this is of mass 4m. So first of all we have to find that at which distance from the center of this planet, this sphere. They have used a word sphere, and yeah, it is I like this word instead of saying, because I have to use multiple terms. It is a heavenly body, it can be a planet, it can be a sun, or whatever. So instead of that I can use the term sphere, solid sphere, from the next time. Okay, so distance between their centers is 6r. Yeah, so we know that from surface to surface distance will be 4r. So let us suppose first we will find a null point, a neutral point, till where uh, at least we have to send it to overcome gravitational attraction of this sphere. So let us suppose it is somewhere here. So the distance, let us suppose, is x. So this distance will be 6r minus x. So first what we are doing, finding the position of that null point at O. At O, F, due to r radius planet, is equal to force due to m mass planet is equal to 4m mass planet. These are my way of representation. These are not uh, getting multiplied with this. So it will be g m m, this is the projectile, upon x square. So origin of this question, starting of this question is same as the previous one, but it will completely go in other way, because they are talking about some velocity of projection. So it will completely go in other way. Oh, this one is of 4m mass. M will get cancelled. Okay. All the m's will get cancelled, all the g's will get cancelled, so we will get 1 upon x square equal to 4 upon 6 minus r 6r sorry 6r minus x whole square. We'll take a root of it. That is why they have given a set value. Otherwise such type of problems are very problematic. 2 upon 6r minus x, we can rearrange it. 6r minus x equal to 2x. It will be 3x equal to 6r. So it will be x equal to 6r by 3, that is 2r. So first thing is done. This is 2r till here. So this is 4r till here from the centers. So in the meanwhile, I'm arranging another sheet to solve this problem. Actually, I lost many. Maybe this one is okay. So now the idea is this is 2r, this is 4r, this is m, this is 4m, and this is our projectile. Now actually we will take two different conditions. One, when projectile was here. Two, when projectile is here. So we'll give it velocity here just in order to reach this point. So I have mentioned earlier PO, so I'm writing it P. So let V be the velocity to take projectile from P to O. Then total energy at P is equal to total energy at O by conservation of energy. Now total energy at P will be the kinetic energy given to that body plus potential energy of this sphere and the projectile, but instead of plus there will be minus because potential energy is negative. G m upon r plus potential energy due to this sphere, again minus. What is the distance from here to here? 5r, because total distance is 6. This is 5r distance. Yeah, of course, its influence is also there. So G 4m m upon 5r. 5r, this distance is 5r from the center of this, and its mass is 4m, and that will be equal to when it reaches here. Then kinetic energy is exhausted. No kinetic energy. We have given it a minimum velocity so that till reaching this point its energy, kinetic energy is exhausted. So no more energy is here, kinetic energy is here, but potential energy due to this planet on this and due to this planet on this is there. So potential energy will be minus g m m upon 2r due to this, minus g 4m m o 4m m upon, and how much, 4r. This is 4r, 2r it has traveled, so 4r distance. Now we can solve it. M throughout cancel, so I am not writing it. Gm upon r minus 4gm upon 5r equal to minus gm upon 2r minus gm upon r. Cancelled, and that's all. We are very close to solve this question. It was a very lengthy question, actually not difficult one, but lengthy. LCM 10R, so it will be 8gm minus 5gm what else, v square equal to, this is 3 to the 6, 6gm upon 10r, that is 3gm upon 5r. So v will be equal to root of 3gm upon 5r. That's all. A rocket is fired vertically with speed 5 km per second. How far from Earth does the rocket go before returning to the Earth? Actually, whenever we, if the similar question would be asked in earlier chapters, जैसे एक बॉल को थ्रो किया गया अपवर्ड, we would directly using equations of motion, but not in this case. ऐसा नहीं कि ये ग्रेविटेशन का चैप्टर है, that is why. No, because speed is very high. This is very high speed. So in the same way, I can rephrase this question. A rocket is fired vertically with a speed of 5 km per second. Can you use equations of motion, 3 equations of motion जो दे रखी हैं, v equal to u plus at and all that, to find how far does the rocket go? Then answer is no, because those equations of motion are applicable if acceleration is constant, and we know that for with altitude, with height, acceleration changes, acceleration due to gravity changes. So these equations are no longer being applicable here. So remember this thing, for such a high speeds, that is any speed above 100 meter per second, any speed above 100 meter per second is not suitable for equations of motion, and anything which is above 1000 meter per second, that is 1 kilometer per second, is definitely not. So what else we can do? we can use the concept of energy, and that is the best way to solve such kind of problems. So what we are going to do is we are going to use kinetic energy initial plus potential energy initial equal to kinetic energy final plus potential energy final. What is kinetic energy initial here? Half m v square. Instead I have to write u square. That will look like, as if we are using initial velocity, minus gmm upon r on the surface of earth. At the topmost position it will stop there, kinetic energy is 0, but there is some potential energy gmm upon, let us suppose, at h height, r plus h. I hope this is not a big deal here. This is earth, this is that object, we have thrown it with this speed, and we know that on earth escape speed is 11.2 kilometer per second. It is much lower than that, so it will not escape, but it will go up to a certain height. Let us suppose this h, this r. So there potential energy will be minus gmm upon r. So mm will get cancelled throughout, small m will get cancelled. So what else? Then we have v square by 2 minus gm by r equal to gm by r plus h. We'll put the value here, everywhere. Anything else we can do? Yeah, we can do, but that will make the calculation bit problematic. So okay, directly I'm putting the value 5 kilometer per second, that is 5000 kilometer. Instead of this I will write it 5 into 10 to the power 3. That is much easier. So v square means 5 square, that is 25, into 10 to the power 3 square means 10 to the power 6 upon 2. This is v square, minus 6.67 into 10 to the power minus 11 into mass of earth 6 into 10 to the power 24 upon radius of earth 6.4 into 10 to the power 6 equal to, here I am not putting values right now, gm upon r plus h. First we will solve entire this portion. So once again my approximate calculations, 6 ones are 6 approximately, and here 10 to the power 13, ये भी जाएगा 10 to the power 7, so this will be 12.5 into 10 to the power 6 minus 6 into 10 to the power 7, and that is equal to, oh sorry, it is with a negative sign, otherwise there will be a mess. Oh, again I have to use another paper. So here, orientation, It looks like 12 minus 6, but no, it is actually 12.5 into, in fact, this is much better, 1.25 into 10 to the power 7. Getting my point? I have decreased this and increased this. Minus 6 into 10 to the power 7 gm upon r plus h. We'll subtract them, it will be 4.75 into 10 to the power 7 with the negative sign, minus 6.67 into 10 to the power minus 11 into 6 into 10 to the power 24. Right now I am not putting the value of r, so anything we can do here? Nothing. Negative negative cancel, r plus h taken this side, r plus h is equal to 6.67 into 6 into 10 to the power 13 upon 4.75 into 10 to the power 7. Now, is there any more approximate calculation here? 8 6 48 approximately, 8 8 64 approximately. 6 will get cancelled, but it is not exactly 8, it can be 8.1 I guess, so 8.1 or 8.2 whatever. So I'm taking the risk of it. See, these are approximate calculation, it saves time. But if you have enough time in the exam, you can divide it. So this is r plus h actually. So h equal to 8.1 into 10 to the power 6 minus r, and what is the value of r? It is 6.4 into 10 to the power 6. That is, I think 1.7. 1.7. This time I'm not going for those approximate calculation. This time I'm doing it correctly. 1.7 into 10 to the power 6 meter.